This is the last section in Unit 7. This is 7.7. It's really just a spiral review. The I can statement here is I can recall and practice skills we have learned. So all of this is a review of things that we've already learned how to do. We want to recall these. We want to get these in our head again so we don't forget these, because a lot of these are going to come up over and over and over again. So please keep these in mind. If you know these already, great. You can feel good about that. If you don't, make sure you practice this and lock these things away. So on the warm-up number 1, it says, what formula relates distance, rate, and time? Well, that one's pretty easy. It almost gives it to you. Don't forget this. Distance is equal to rate times time. D equals RT. So the distance that you go is how fast you're going, the rate of speed times the time that you go that fast. And then there are 3 methods we have learned for solving systems. So if we're going to solve a system, you've got 3 choices. One is graphing. The next one was substitution. And the last one, probably everybody's favorite, elimination. Okay. What does absolute value mean? Please don't forget this. Lots of people do. Absolute value refers to the distance from zero. Distance from zero. Okay. What is an x-intercept? It's where the graph crosses the x-axis. Where graph crosses the x-axis. And it might not be a bad idea to write down what those coordinates look like. Remember, on the x-axis, we've got an x-coordinate, and then the y-coordinate is always going to be 0. So it's a number, comma 0. Okay, the y is always 0 when we find an x-intercept. Okay, write the equation of a vertical line. Let's see, vertical line, that's straight up and down. So that's going to be x equals a number. Right next to it down below here, it says write the equation of a horizontal line. So that's going to be y equals a number. And what is the slope of that vertical line? Okay, so we could say a couple things. We could say no slope, or we could say it's undefined. And what we mean by that, undefined, what we mean by that is this line, when it's vertical, when it's straight up and down, it is so steep, there's no number that represents how steep that is. We would have a rise, but we wouldn't have any run. We'd end up dividing by 0. So we'd have a number for the rise. So the rise would be a number, and then when we try and divide by the run would be 0, okay? So that's why we can't do something like that. What's the slope of a horizontal line? Horizontal line would have a slope of 0. Whoops, let me make that look like an M. Slope of 0. And then what would the following transformation do? So we've got multiplying by 4 outside the parentheses, and then inside with the x we've got this -2, and then outside again we've got that -3 or that -3. So what this is going to do is this is going to be a vertical stretch. And we could put factor of 4. And then remember, if we change the x inside the parentheses before it makes the shape, it does the opposite of what you'd think. So this is actually going to move it to the right 3 units. It does move it horizontally, but it does the opposite of what you'd think. Whereas outside, subtracting is going to do exactly what we think in the vertical direction. It's going to move it down 3. Now, there are 2 operations so far that we know of that cause domain issues. What are they? They are division, and we've talked about this recently. Division can't divide by 0. And then we've got another one, even roots. Okay? Can't take the even root of a negative number. So can't take even root of negative number. Okay? All right, let's see. What does it mean for a number to be a solution to the equation? So if it's a solution to the equation, it makes the equation true. So let's just write makes equation true. And then could these matrices be multiplied? Whoa, out of the blue, just some matrices here. So can I multiply A, which is a 2 by 3, with B, which is a 3 by 1? The answer to that is yes, because the inner dimensions are the same. And then for this next one, it says, what if we switched these around so that they were in the opposite order? So it was a 3 by 1 times a 2 by 3. Well, the answer to that is no, because the inner dimensions are not the same. And then the last warm-up question right here, it says, what is the formula for the distance between 2 points? Now, we haven't talked about this here. It's been a while since you saw this. You should have learned this last year, but if not, we are going to go over this again this year, how we develop this and how we use this formula. But the formula looks really complicated. It's really not too bad. It's based on the Pythagorean theorem. So hopefully you remember this. So it's x2 minus x1 quantity squared. So when we say quantity, we put that in parentheses and then we square it, plus y2 minus y1 quantity squared. So we've got a big D equals big huge square root. So that big D stands for distance. So distance equals big square root x2 minus x1 quantity squared plus y2 minus y1 quantity squared. One little caution about this, a lot of people will look at this and they'll say, hey, I remember about squares and square roots. They undo each other. You can't just eliminate these right here because these are not factors, okay? So you've got to be a little bit careful with that. Now, as we come down here and take a look at number 1, the instructions are important here because it just says discuss and set up a plan for solving each one. You do not need to solve these, but you will need to solve these on the assignment. So all we're going to do right now is just get these set up, remind ourselves how we did these problems in the past, and then we'll allow you to solve these when you get to them on the assignment. So on example number 1, it says IFA carries 2 brands of plant fertilizer containing nitrogen and water. Gentle Grow is 2% nitrogen and Sun Saver is 10% nitrogen. Why it needs to combine 2 types of fertilizer to make 80 liters of a solution that's 4% nitrogen. How many liters of each brand should he use? Now, you might recognize this problem if you've got a good memory. We did one like it. It's not exactly like it. So even if you went back in your notes, you could find another model for this, but it is not the same problem. Now, one little caution about this, how do we write percents in equations? We write them as decimals. So let's make sure we write them as decimals, and let's be careful when we write these as decimals. So let's define some variables. Let's say x equals Gentle Grow, and I'm just going to write gentle. And then we're going to write y equals, this would be Sun Saver. Okay, Sun Saver, Gentle Grow here. Now, I'm going to put number right here and number right here because we're looking for the number of liters. So I'm just going to put a liter sign right there. So when we put that down, if we're talking about like the number of rides or the number of coins or different things like that as we've done before, we're looking for a number of those. So we couldn't have a fraction or a decimal answer. If we're talking about liters, we could have a portion of a liter. So we could have 25.5 liters or different things like that. So the fact that he needs 80 liters altogether means we're going to have x plus y is equal to 80. And then what we're going to do is we're going to keep track of so this has to do with the total amounts. And then we're going to keep track of the percents. So Gentle Grow, remember, is 2%. The Sun Saver is 10. And then the final solution, that 80 liters, needs to be 4%. Now, this is not an equation, but it helps us write down the next equation. I hope you remember this uniformity of this technique here. We're going to take this many liters of Gentle Grow, and we're going to multiply it by 2%. So this is where you've got to be careful, 0.02x. We're going to take this number of liters of Sun Saver, and we're going to multiply it by 10%. So this is going to be 0.10y. Now, again, I've mentioned this before. I really like putting the 0 there, even though it's not necessary. If this one has 2 decimal places, let's go ahead and just make sure everything's got 2 decimal places. That when we do any elimination or anything like that, we can line them up and make sure that we don't make any silly mistakes. So this one right here is going to be 4% of 80. So this is going to be 0.04 times 80. And then what we would do is we would come up with that number right there. So here's what we have. This is what we would be solving. X plus y is equal to 80. 0.02x plus 1.0y. 1.0y is equal to, and if you multiply those together, you actually get 3.2. So this right here is the setup. So this is the work that we go to get there, and then you've got a system of equations there that you can solve by elimination or substitution. I think most people really like doing elimination on those. That tended to work a little bit better. But again, substitution would be just fine. Okay, let's take a look at the next one. On example 2, it says Jonathan rode downstream 1 mile with a 1 mile per hour current for 4 hours, but the return trip took him 6 hours, so it took him longer because he was going against the current. It says find the rate of his rowing and the distance of a one-way trip. Now, this is set up in a slightly different fashion than some of the problems that we've seen before, but if we approach it with the same setup, with that distance equals rate times time, we should be able to solve this without any problem. Now, a quick reminder, as we've mentioned before, whenever we do problems that involve current or wind, we've got to make sure that we put the variables in the correct order. If we don't put them in the correct order, we're going to get this wrong, and the correct order is this: whatever the object's speed is, plus or minus the speed of the current or the wind, depending on the situation. And in this case, we're dealing with a current in water, so it's going to be like this. So the first thing we're going to do is, it ends with a question that says, find the rate of his rowing and the distance of a one-way trip. So we're going to write this. R is the rowing, so we could say rowing speed or something like that, okay? And then D is going to be the distance. So we'll say D equals distance. Okay, so remember the formula is this, and I'm going to write it backwards for a reason. It's going to be rate times time equals the distance. So I'm going to write first an equation for downstream. So I'm going to write down right here, and that would be with the current. You're with the current going downstream, and then upstream right here, this is against. Okay, and that against right there, that ought to be enough to remind us there. So when he's going downstream, here's what he's got. He's got how fast he can row plus the speed of the current, which is 1 mile per hour. So it's going to be R plus 1. And then we know that it took him 4 hours. So we're going to do times 4. We don't know the distance, though, so I'm going to put a little d right there. Now, it looks almost exactly the same when he's going upstream, but this time he was going against the current, so that current was working against him. It was subtracting from his speed, which is why it took him longer. It took him 6 hours, okay? And that's the same distance. Now, you'll notice that this one, we've got some distributing to do and some things like that, but this one is all set up for substitution. We can basically just kind of link these two together, and we can say, look, wherever there's a D, I can put this stuff right here, or wherever this D is, I can put this stuff right here. So if I wanted to put the R plus 1 times 4 over here, that would be fine. If I wanted to take the R minus 1 times 6 and put it over here, that would be fine. You're going to solve that. You're going to figure out what R is, and then once you know what R is, then you can figure out the distance of the trip. Okay, let's slide down and take a look at example number 3. It says solve each inequality, graph the solution, and write the answer in interval notation. So what should we do first? Well, if you take a look at this, this has absolute value in it. Whether we were solving an absolute value equation or an inequality wouldn't make any difference. First thing we'd want to do is isolate the absolute value. So I'm going to write, I better just go ahead and write it, absolute value, okay? Now, how many cases are there? When we're solving absolute value, there are going to be 2 cases almost every single time. Now, we do have those weird cases where we're comparing it, we isolate it, and we compare it to a negative or something strange like that. We do have to be on our toes, but most of the time we're going to end up with 2 cases. So the first thing we'd want to do is we're going to subtract 3. Subtracting doesn't change the direction of the inequality, so we have x minus 4 in absolute value, and then this is going to be less than or equal to 7. And then we're going to break this into 2 cases. So this is going to be x minus 4, and we're going to put a negative 7 here. Remember, when we introduce a negative, we're introducing an opposite. So we change this to the opposite direction right here. And then x minus 4 less than or equal to 7. Now, the trick is you've got to remember what word goes between here. So remember, less than is an and we thought of that as the word land, and if it's greater than, then that's got to be an or. This is a less than, so the word that connects the 2 of these would be an and. So what we're looking for here is we're looking for the overlap. We're looking for both types of shading, okay? So we're looking for one shading to go this way, one shading to go this way, and if there's any overlap, that's what we're going to be after. And because it's an equal to, we're probably looking at an interval that looks something like this with closed brackets. Okay, all right, let's take a look at the last one here. On this last one, we've got a, let's see, this looks like a matrix, but remember we've got absolute value bars on there. These big solid bars are not absolute value, but they are asking us to find the determinant, okay? So to find the determinant, we could do diagonals. If you'd like to do that, you'd be welcome to, but I would really encourage you to do expansion by minors or cofactor expansion once in a while. So that's what the hint is right here. Which row or column would be the easiest to expand on? Well, that would be column number 1. That's going to be the easiest because it's got a 0. So here's how this works. We take the sign associated with this position. So if we're going to do this row, or sorry, this column, remember we've got this checkerboard of pluses and minuses all the way throughout here. So it looks something like this. So we take the sign associated with that position, which is positive. We take the element right there, which is a 1, and then we cross out that row and column, and we find a little 2 by 2 determinant. Okay? So we do that, and then we're going to do the next one in that column, so that's going to be this guy right here. The sign associated with that position is negative. The number that's there is a 1, and then we cross out the row in the column. So we have a 1, a 1, a -2, and a 3, and we've got a little 2 by 2 to find, 2 by 2 determinant. And then the sign associated with this one is positive, but notice this is why we chose that first column, because it's a 0. So it really doesn't matter what that minor is, but let's go ahead and write it 1, 1, and then 1, -5, okay? So this is just going to turn into a 0 right there. We've got two 2 by 2 determinants. We multiply this one by 1, that by -1. Anyway, good review right here. Hopefully most of that made sense. If not, please ask some questions. Please go back, take a look at your notes, look at videos and different things like that. These skills are going to come up again, so you really want to make sure that you've got them for the future when you need them. All right, good luck.